today we are going to factor polynomials completely using grouping and identities. To factor an expression means to write an expression as the product of factors. So if we have x squared plus x minus 12, we need to rewrite that as what two numbers could multiply to negative 12 and add to 1. So that would be negative 4 and 3. So we then could write this as the product of x minus 4 times x plus 3. That's a review from Algebra 1. And we will use other methods of factoring as well. Most commonly, we need to check for a greatest common factor when we are beginning a problem. So if we have 6x cubed plus 3x squared plus 24x plus 12, we want to try to think about something that goes into each of these terms. And when we do, when we figure out that it is 3, we are going to factor out of 3 from each term and be left with 2x cubed plus x squared plus 8x plus 4 times 3. If we're factoring by grouping, we're going to continue that problem we were just working on, and we are going to take inside of our parentheses and split it up into pairs that have greatest common factors. So we're going to rewrite this grouping 2x cubed plus x squared and grouping 8x plus 4. So we're going to rewrite that with parentheses to say 3 times 2x cubed plus x squared plus 8x plus 4. So if we look at our individual groups here, we see that they have a common factor between those two terms. So we're going to take out that common factor. So 3 times the common factor between 2x cubed and x squared is an x squared. So we're left with, inside our parentheses, 2x plus 1. And in our second set of parentheses, our greatest common factor is 4, so plus 4. We're going to factor out of each term and be left with 2x plus 1. Now inside our parentheses should be the same. Since they are the same, we're going to factor this 2x plus 1 out and be left with 2x plus 1 in our parentheses times what was left from before. So x squared plus 4. Don't forget about our 3 from the beginning, and then we have fully factored this polynomial. Identities show equivalent ways of writing the same expression. So we're going to use these polynomial identities when we're factoring to rewrite our polynomials. So make sure you have these down, and when you're ready, we're going to solve this next problem. 125x cubed plus 64y cubed. So our first thing we're going to look at is if this problem fits any identities. So if we take a look back at our identities and our problem, we have cubes in our problem, and we have a sum of cubes identity. Both of our variables are raised to the third power, and our coefficients are perfect cubes. So we're going to use the sum of cubes identity to factor this expression. The first thing we want to do is rewrite our polynomial in order to show the sum of cubes. So 125x cubed plus 64y cubed is equal to if we have 5x cubed, then we would get 125x cubed. And 4y cubed would give us 64y cubed. So now we're going to recall the sum of cubes identity, which is x cubed plus y cubed is equal to x plus y times x squared minus xy plus y squared. So we have x cubed plus y cubed is equal to x plus y times x squared minus xy plus y squared. So we're going to substitute 5x for x and 4y for y to get 5x plus 4y times 5x squared minus 5x times 4y plus 4y squared. We're going to simplify this expression so that we have 5x plus 4y. 5x squared gives us times 25x squared. Negative 5x times 4y will be minus 20xy. And 4y squared is plus 16y squared. So we then factored this polynomial by using our sum of cubes identity. That's it.